This presentation covers Chapter 4, the effect of temperature and pressure on the volume of gas IGCSE, Class 9 and 10 Chemistry Curriculum. This slide compares the arrangement of particles in solids, liquids, and gases. In a solid, the particles are closely packed and arranged in a regular structure. The intermolecular bonds are very strong. In a liquid, the particles are slightly less close packed, and there is some structure. The intermolecular bonds are strong. In a gas, the particles are spread out. The intermolecular bonds are weak. As particles gain energy, they can either increase their kinetic energy and vibrate more, which changes their temperature, or they can break their intermolecular bonds, which changes their state. The kinetic particle theory of matter. All matter is made up of tiny particles like atoms or molecules. These particles are always in motion. Solids. Particles vibrate in fixed positions. Liquids. Particles move around each other freely. Gases. Particles move rapidly and randomly in all directions. As temperature increases, particle motion increases, giving them higher energy. The spacing and forces between particles differ between the states. There are strong forces and close packing in solids, moderate forces in liquids, and weak or no forces in gases. This theory explains diffusion, pressure, expansion, and phase changes. This slide shows a model of a chrome alum crystal and describes the arrangement of particles. Solid. Particles only vibrate about fixed positions and have a regular structure. Liquid. Particles have some freedom and can move around each other, and they collide often. Gas. Particles move freely and at random in all the space available, and they collide less often than in a liquid. Changes of state. Melting is the change from a solid to a liquid. Heat energy breaks the strong bonds between particles. Freezing is the change from a liquid to a solid. Particles lose energy and settle into fixed positions. Boiling is the change from a liquid to a gas. Heat causes particles to move faster and escape the surface. Condensation is the change from a gas to a liquid. Particles lose energy and come closer together to form a liquid. Key points. For pure substances, these changes occur at fixed temperatures. The temperature stays constant during the change of state. These changes involve a gain or loss of energy, not a change in temperature. This table shows the melting and boiling points of various substances. Aluminium. Melting point is 661 degrees Celsius. Boiling point is 2467 degrees Celsius. Ethanol. Melting point is negative 117 degrees Celsius. Boiling point is 79 degrees Celsius. Magnesium oxide. Melting point is 827 degrees Celsius. Boiling point is 3627 degrees Celsius. Mercury. Melting point is negative 30 degrees Celsius. Boiling point is 357 degrees Celsius. Methane. Melting point is negative 182 degrees Celsius. Boiling point is negative 164 degrees Celsius. Oxygen. Melting point is negative 218 degrees Celsius. Boiling point is negative 183 degrees Celsius. Sodium chloride. Melting point is 801 degrees Celsius. Boiling point is 1413 degrees Celsius. The effects of temperature and pressure on the volume of a gas. Heating a gas increases the speed of its particles, which leads to more collisions and therefore higher pressure if the volume is kept fixed. Charles's law states that the volume of a gas is proportional to its temperature at constant pressure. This means heating a gas expands it and cooling contracts it. The pressure of a gas increases when its volume is decreased through compression or when its temperature is increased, which causes more energetic collisions. A real-life example is a bicycle pump getting hot when the air inside is compressed. Boyle's law. Boyle's law states that the pressure and volume of a gas at a constant temperature are inversely related. This means that as the pressure on a gas increases, its volume decreases and vice versa. Diffusion. Diffusion is the movement of particles from a region of high concentration to a region of low concentration. It occurs in gases and liquids, where particles can move freely. Diffusion is faster in gases because the particles have greater speed and more space between them. Lighter particles diffuse faster. For example, ammonia diffuses faster than hydrogen chloride. Diffusion demonstrates the random motion of particles described by the kinetic particle theory. An example is the formation of a white ring when ammonia gas and hydrogen chloride gas meet in a glass tube. This slide illustrates the key principle of the kinetic theory. Particles of matter are always in motion. The image shows gas molecules moving randomly inside a container. Thank you for learning with us.